Before we start, just check whether you have this worksheet with you.
Sorry, can you say that again?
Do you have this worksheet with you?
Yeah.
Yeah. Okay. Hi, Nico. Okay. So what happens is that these 2 hours we just going through whatever question you have with this worksheet. Okay. So for question 1 to 5, any question? MCQ. So what about Nico? Okay, no question. Then what about 6 to 10?
Wait, can you go through question 2?
Question 2? Okay, can. Okay, question 2. This one, what happens is that you look at A, B, C, D, right? They didn't give you the exact answer at the end. What has happened is that they want to see the steps. Okay, this is a question about how many molecules of chlorine gas you have. So you need to use the Avogadro constant, which is 6 times 10 to the power 23. So 1 mole of anything, you have 6 times 10 to the power 23 of that molecules. This is Avogadro constant. In 1 dm cube of air, you will have chlorine gas of 0.005 mg. Okay, so what happens? You need to find number of moles first. Number of moles of chlorine, 0.005 mg. 1000 mg is 1 gram. So mg convert to gram, you divide by 1000. This is gram. And mole is equals to mass over mr. Okay, this is gram. So I need to divide by mr. mr of chlorine is 71. Look at your periodic table, 35.5 times 2. Chlorine gas is Cl2. Okay, so this is the first step. Second step, from number of moles, I convert it to how many molecules I have. So basically, number of molecules is number of moles times this 6 times 10 to the power 23. If you sub it in the number of moles, then you will get this answer is B. Okay, so this is for number of molecules. So sometimes the question can be a bit tricky. They like to ask whether is it molecules or atoms. If you see atoms, that means 1 chlorine, Cl2, you have 2 chlorine atoms. So if they ask for number of atoms instead of molecules, you need to times 2 overall for how many atoms. Okay, so this is your side note. Okay, any questions? Okay, Nico, do you have any question for question 1 to 5? Anything that you want me to go through?
No.
No, okay. Okay, Kevin, do you have any question?
1, 2, 3.
1 to 5?
No,
1, 2,
1,
3.
2, 3.
1, 2, 3. Okay, question 2 is here. So what happens that they can't tell the concentration is 0.005 mg per dm cube. And 1 dm cube of air, that means I have 0.005 mg. So first thing first, I want to find the number of moles so that I can find the number of molecules. This one is Avogadro constant. 1 mole of anything, you will get 6 times 10 to the power 23 number of molecules or atoms, etc. So this is the magic number that you need to know. So first thing, you convert the mg to gram. So what happens is that divide by 1000, you will get gram. So this is the gram. Number of moles will be equals to mass over mr. So this is your mass, which is in gram, and divide by mr. This is mr. So you get number of moles. So this magic number, they tell you that 1 mole I will get 6 times 10 to the power 23 number of molecules. So number of molecules will be number of moles times 6 times 10 to the power 23. So if you sub in this value, so the whole thing would be equals to this. Is it okay?
Yeah, okay.
Okay. So I just go through question 1. Okay, question 1 is a classic example of how to find AR. So if you realize the definition of AR is actually many different isotopes, I take the relative abundance, which is how many percent I have, I total up, and the AR will be your average. Okay, so the percentage, this is 50%, 10%, 20%, this is 0, don't care, and 20%. So the relative atomic mass would be just the sum of all these. So you use the percentage times the whatever, 90 or 91 or 92, etc. And if you total up, you will get B. So 50% times 91 plus 10% times 91, then sum up everything, you will get 91.3. Okay, this is question 1. Okay, before I continue, Daniel, any question for 1 to 5?
No.
Okay, can. Okay, Kayla, okay?
Yeah, okay.
Okay, so question 3. I have 1 mole of X. This is a compound, and overall I will give 3 moles of ions. That means, right, X is probably a cation ion and an anion. And total overall, I will have 3 ions together. That means it's either 2 to 1 or 1 to 2. Total I have 3 ions. So X reacts with ammonium carbonate to give acidic gas. Ammonium carbonate, it can react with acid or base. If you react acid, that means it's an acid plus carbonate reaction. So I will get CO2 as a gas. If you react with a base, it is ammonium salt plus base. This is acid-base topic. Ammonium salt plus base, you will get ammonia gas. And the question tells you that it's an acidic gas. So acidic gas, these two, this is acidic, this is basic, this gas. NH3 is a weak base, CO2 is an acidic gas. So therefore, X should be a acid because it gives a CO2, acidic gas. So if you look at A, B, C, D, only B and D are acid. I can reject A and C. And look at this, you need 3 ions, therefore CH3COOH, this is ethanoic acid. You get ions, which is CH3COO minus and H plus. And if 1 plus 1 total, I have 2 ions, 2 moles of ions. If you look at sulfuric acid, I will give 2H plus and SO4 2 minus, which is total up, I have 3 ions. Okay, so therefore it should be D because I want 3 moles of ions. Okay, so now I'm done with question 1 to 5. So question 6 to 10, any question? Anyone?
Wait, can I see the answer for 4 and 5?
4? Sorry, can you repeat?
Can I see the answer for 4 and 5?
Answer for 4 and 5? Yeah, sure.
I got 4 wrong. Can you explain the thing?
Okay, can. Okay, so the question says urine containing urea, so this is urea, MR60, they react with nitrous acid. Basically just this equation. The gas produced was passed through NaOH and they measure the final volume of gas. Okay, if you realize, right, the product, this is a gas, CO2 and nitrogen are gas, H2O is liquid. So I don't count in the volume for H2O. But total gas, if you realize that actually the gas, right, they pass through NaOH, which is a base. So what happens is that CO2 is an acidic gas, I remove CO2. So what do I left with? I left with nitrogen. So the final volume of gas is the volume of nitrogen. Okay. So to find the volume of nitrogen, the only thing that I can do is that I'm given the mass of urea and the MR. This is the mass of urea. So number of moles equals to mass over MR. So I will get number of moles for the urea. 0.002 mole. Do you get this? Number of moles.
Yeah, I did.
Yeah, by mole ratio, number of moles of N2 nitrogen should be 0.004 mole nitrogen. So I'll get the mole of nitrogen. After that, I need to convert to volume of gas. There's only one way that links the number of moles to gas, the volume of gas, which is the times 24 dm cube, if you remember. So the volume of nitrogen, number of moles times 24 dm cube. So you get 96 cm cube.
Can you
Okay, Cesar?
explain why cannot use CO2 again?
Why cannot use CO2? Because I have a presence of NaOH. So after the reaction, I have two gas forming, CO2 and N2. And all the gas, it was passed through this NaOH. That means I put the gas inside NaOH, and then after that, I collect all the gas back. So the CO2 will react with NaOH. Why? Because CO2 is acidic. CO2 is an acidic gas and NaOH is a base. There will be a neutralization occur.
Oh, okay, okay.
Okay, 6 to 10, anyone? Okay, Nico, any question? Gabriel? Okay, Daniel? Okay, so 6 to 10. Kevin, any question?
7, I don't know.
7. Okay, 7 is a question about titration. So first thing, I have NaOH, sodium hydroxide, and you are given concentration and volume. So you can find number of moles. After that, there is a dilute sulfuric acid. Was added the beer until one drop of acid turned the solution in the flask color. So basically, there is the neutralization. Okay, this is the end point. That means the exact volume of NaOH and exact volume of sulfuric acid, the exact number of moles they react, so that I have a neutralization occur. So first thing first, write out the equation. NaOH plus H2SO4. I will get Na2SO4 and H2O. If you balance, okay, for titration, if you see question like this, always start with finding number of moles. This one cannot run away. So this one, if you actually calculate out using concentration and volume, you will get the number of moles equals to 0.0025 moles. Okay, so they ask you to find the volume and concentration of dilute sulfuric acid. Therefore, I need mole ratio. When I use mole ratio, bring it over, I will get this 0.00125 moles of sulfuric acid. This is your number of moles. But A, B, C, D, they give you volume and concentration. So what happens is that just calculate all the number of moles. Calculate all the number of moles. There will be only one answer that gives you this number of moles. Okay, Kiza? Okay, 8, 9, 10, any questions?
8 also.
8. Okay, this one, can I tell you again, it's titration. So if you see titration, please craft out the equation. If they're not given, please craft out the equation. I have this sulfuric acid, the concentration is given, and I have a volume given for this base. Okay, barium hydroxide, sulfuric acid. Okay, look at the voltmeter. There will be electricity. That means I can measure using voltmeter the voltage if there's electricity. If there's electricity, I need the presence of mobile charge carrier. This is your chemical bonding to carry out charge. That means anything more than 0 voltage, I need charge carrier, mobile charge carrier. In this case, is your ions. Your ions are from H2SO4 and barium hydroxide. Craft out the equation first. Barium hydroxide plus H2SO4. I will get barium sulfate and water. Okay, why there is a 0 here at volume 15 cm cube is because there is an exact mole of barium hydroxide and the exact accurately sulfuric acid. Same moles, they react, there will be no excess for both, and I will only have barium sulfate. So at voltage equals to 0, I only have barium sulfate present. I don't have excess base or acid. So the ions are from the base and acid because they can ionize to form ions. This is the definition of acid and base. Alkaline, acid and alkaline. So when you have exact same number of moles to form this no excess, and barium sulfate is the insoluble PPT. Therefore, I don't have ions at that point of time. I don't have ions, therefore it's 0 voltage. And this one, you can determine that this will be your endpoint. Okay, this will be your endpoint. 15 cm cube is the neutralization, where the neutralization occurs. So you have concentration and the volume is 15 cm cube. Find out the number of moles of H2SO4 because you have your volume and concentration. You get that H2SO4, the number of moles is actually 0.0225. By mole ratio, your barium hydroxide should also get 0.0225. This is your number of moles. The question asks you to find the concentration of barium hydroxide. I have number of moles ready. To find concentration, concentration equals to mole over dm cube. I need the volume. The volume, it is given here, 30 cm cube of barium hydroxide. So to find concentration, you always need to find the moles and the volume. I have moles ready, 0.0225, and I have the volume. Volume is equal to 30 cm cube. Okay, Kizan?
Yeah, okay.
Okay, 9 and 10, anyone? Okay, if not, 11 to 15. Okay, just check. Question 13, do you have the option D? Because for my worksheet is blank.
Don't
Don't have. But they all calculate out what is the answer. Okay, if A, B, C is wrong, right? D is confirmed the answer, but what is D?
Hold on, let me do it.
Okay, Gabriel, have you calculated out what is D?
I left the question blank.
Okay. Okay, what about yours? Try. Try question 13. If you all leave it blank, try question 13. Okay, I'll show you how to start. If you have unknown relative abundance, normally they give two unknowns, okay? And they give you the, at the end, what's the AR? You always start with this. You let this be X%, the other one be 100 minus X%. That means what? AR will be equals to X% of 39 plus 100 minus X% of 41. And do the algebra. Okay, come on, anyone get the answer?
I think it's 93%.
Yeah, it's 93 for X, and the other one is 7%. Okay, Gabriel get it? 93 and 7. Okay, what about Nicole? Okay? Okay, so just emphasize if you see the question asks you to find two unknown abundances, the percentage. The only thing is AR given and the isotope given. Just use X and 100 minus X. It's always like that. And from the equation out, you will just use math and do it. Okay, 14, 15, any question? Okay, if not, 16 to 20. Okay, Daniel, any questions?
17, I don't know.
Sorry?
17, I don't know.
17. Okay, so they ask you to find the charge of Si4O10. Okay, I write it bigger. I have... Okay, first thing first, write down the charge of those you are familiar with. I will need to find the charge of this, so I don't care, I just box this thing out. So other than this, the compound has Mg and OH. So Mg, if you look at your periodic table, is a +2. OH is -1. This is your common ions that you need to know. You know, OH is a minus. Okay, overall, this whole thing should be equal to 0. If it's a compound, that means if the on top don't have a charge, right? Everything, the overall charge should be equal to 0. NaCl, the overall charge equals to 0. MgSO4 overall charge equals to 0, etc. Always equals to 0. And if you have a Mg3 times 3, OH2 times 2. So calculate what is X. So X should be equals to -4. Okay, Kizon?
Yeah, okay.
Okay, anyone? 16 to 20. No, Okay, then next 21 to 25. Okay, there's no 25, but anyway, 21 to 24. Actually, just a question. Have you all finished everything?
Okay.
Oh, yes. Okay, y'all can do first. Okay, let's open up any MCQ question. If you have done your MCQ, whatever, if you want to ask question, then just ask me. If you're not done, then just use this time to do it first. Okay, if you are done with MCQ, right? Like while you are doing, if you are done, or if you have done, can you all text me? Just let me know. Okay, Kivyon, come. Let's go through question 22. You texted me, right? Okay, question 22. It is the heating of 4 metal nitrate. If you realize, right, all of them have 2 NO3. They are times 2 of NO3. That means overall the MR, everything just plus 1 to 4. So purely, you can combine all the MR and find number of moles, or alternatively, just look at the cation, because everything is NO3 times 2. If you actually write down all the AR for your lead, copper, magnesium, calcium, you will get 207, 64, 24, and 40. This is your AR for individually each of the cation: lead, copper, magnesium, calcium. So all of them are 10 grams. The mass is the same. Number of mole equals to mass over MR. So if your mass is constant, can you just ignore? So the lower the MR, the higher the number of moles. Of course, you can actually spend more time calculate all the number of moles out, but the faster way, just look at which one is the lowest MR, aka highest number of moles, to produce the greatest mass of NO2. You will realize that the mole ratio is all the same. So the fastest way, compare the MR so that you get the highest number of moles. If the number of moles is the highest, by mole ratio, your number of moles of NO2 gas is the highest. Can follow, Kivyon?
Okay.
Okay, so therefore, just choose the lowest MR, which is Mg. Okay, Gabriel, question 23, right? Okay, first thing first, S2O7 react water to produce sulfuric acid and oxygen. You need to write down the equation in order to find the volume of oxygen. S2O7 reacts with water. You need to translate the word into chemical equation. Sulfuric acid, H2SO4, and oxygen. Okay, balance this thing. This is your balance equation. If you are not comfortable on writing half, right? Just times 2 for everything. Okay, if you balance already, this is the balance equation. They want you to find the volume of oxygen when 0.704 gram of S2O7 is reacted. 0.704 gram, if you convert it to number of moles, just divide by mR, mass over mR equals number of moles, and you will get 0.004 moles. By mole ratio, half it, okay? So when you want to convert it to volume, if it's a volume of gas, you only have number of moles, right? The only way is to times 24 dm cube. This you will get 48 cm cube. Okay, I think the only hard part is to just need to craft out that balanced chemical equation.
If you put 2 for the S2O7 and then 7 for O2, will it still be balanced?
If you put 2 here, S2O7, and you put 7 here, is it?
Yeah.
No, because there is a O4 here. Right? It's not
Oh,
balanced.
okay, okay.
Okay, I just times 2 for everything. Let me just write out the proper one. 2, 4, 4, 1. Okay, we're on question 24, right? Okay, they tell you that this compound, KHSO4, this thing, they heated strongly and decomposed. The loss in mass, okay, always remember loss in mass, right? For decomposition is always your gas. The loss in mass when you heat, they're always the gas. Okay, from the equation, we realize that we have two gas. So the loss in mass will be these two gas. You got two ways to do it. You either calculate the mass of this and you just minus off from the 20.4, or you calculate the mass individually for H2O and SO3. Okay, so how do I start? If you want to find the mass of whatever product, right, the only way is to compare mole ratio. To compare mole ratio, you need your number of moles. Okay, number of moles of solid, this KHSO4, they give you the mass. I'll just skip some steps. So MR, just calculate yourself MR. You will get number of moles equals to 0.15 mole. Okay. So by mole ratio, this one is half of it, 0.075. Same thing, 0.075, 0.075. As just now what I said, you got two ways of doing it. You either calculate this and you minus off. So this mass would be actually 13.05. Number of moles times MR, you get your mass. Okay, if you calculate the mass of gas, you get this. So first way is to use 20.4 gram minus 13.05. Second way is that 1.35 gram plus 6.00 gram. At the end, you still get 7.35 gram. Okay, emphasize loss in mass means gas. So anything that remains, just either solid or liquid. Okay, Kiva?
Yeah, okay, thank you.
Okay, 26, right? Okay, bro. Okay, if you realize, right, this whole chunk here, right, is quite useless, except the last one. Okay.
This is 27 though.
Sorry, who is talking?
This is 27. I wanted 26.
27. Oh, 26. Okay, here. Sorry. Okay, so what happens that they ask you for percentage purity of tin ore, which is this SnO2. If you look at percentage purity, what happens is you work backwards. Find the product first and then you work backwards. 600 gram, this is your percentage purity is actual over expected. Okay, if you are doing percentage purity or percentage yield, always use this formula. Okay, actual over expected, this is like in your own words, the real chemical way of, like chemistry way of writing this theoretically and actual experimentally. But we just write actual over expected. Okay, 82 gram of tin, which is this, always use the mole ratio. So first thing, I want to find number of moles, 82 over 119, this number of moles of Sn. By mole ratio, this one, number of moles of Sn is equal to number of moles of SnO2. After what happened? I need to find the actual mass of SnO2 inside this ore. So the mass using mole times mr give you mass. So mass will be equals to mole times mr. mr of SnO2 is given 151. Number of moles. This is number of moles. Okay, when you are doing this kind of question, right, basically they don't give you the final answer, they give you the step-by-step whatever. Don't need to do any calculation, just write, copy and paste. Number of moles, you get the mass. And then we know that mass, the percentage purity is the actual mass over the expected mass. Expected mass is 600. And the actual mass is this. So percentage purity will be equals to 151 times 82 over 119 divided by the actual mass times 100. Okay, actually if you bring it over, it should be 151 over 600 times 82 over 119 times 100, which is actually this. Okay, the one that they gave you, right, no matter whether is it percentage yield or percentage purity, is always actual over expected mass. And the mass that they are given to you, that is always your expected mass. What you're expecting. The one that you're calculating out, the mass, is your actual mass or your experimental mass. Or if you cannot remember like this, always remember this one is bigger. The actual one is like smaller in number. Okay? Any question for 26? No? Give yourself some time to copy and then you go to the next question, 27. Okay, I'll go to the next one. Okay, 27. So the first chunk of that whole paragraph is quite useless except the last question. Last sentence. 20 cm cube of this. react with 80 cm³ of oxygen. What would be the final volume of the mixture of gas? That means, right, I have CO2 and SO2. It is in room temperature, so this is not a gas. So I only have these two. And you need to take in account whether this oxygen is excess or not. So the mixture of gas, right, they might have CO2, SO2, and oxygen. So for this kind of question, okay, for more concept question, this one, volume is actually very special. You can use volume to directly compare mole ratio for gas. Can I repeat again? For volume of gas, you can directly compare mole ratio using volume. That means what? If I have 20 cm³ of this CH3SH, by mole ratio, this one I should use up then 60 cm³ of oxygen, because 1:3 times 3. This is what I use up. Okay, so I left with 20 cm³ of oxygen not used. Okay, same thing, by mole ratio, I can calculate out the volume of CO2 and SO2, which is actually 20, 20, by mole ratio of CH3SH. If you total up everything, the volume of gas of everything should be 60. Can I repeat again? Volume of gas, right? You can use mole ratio. Only for gas. Why? Because this one just for your understanding only. Don't need to memorize it, whatever. Why volume of gas is actually can use mole ratio? Because 1 mole of gas always occupy 24 dm³. So it is directly proportionate. Okay, Nico? Okay, okay, next one, 28. Okay, sodium carbonate react with the HCl. There are 2 steps and the reactions they are given already. So 25 cm³ of the sodium carbonate and HCl concentration is given. Initial bill rate reading and final bill rate, this one is your practical. If you have done your practical, basically this is your first reading, this is your second reading. And the in-between value should be your volume of HCl used up. Specifically, they tell you that the initial reading is before step 1, then the final reading is after step 2. That means what? This one, the volume of HCl recorded, it is used for step 1 plus 2 together. Okay? Step 1 plus 2 together. Based on the recording, they want you to find the concentration of sodium carbonate. Sodium carbonate volume is given, therefore I need to find the number of moles. Okay, this one. So volume of HCl is 15 cm³. Find the number of moles first. Number of moles of HCl in total, because I have the concentration already. In total, I will get number of moles equals to 0.0015 total. This total, that means step 1 plus 2. That means this one plus this one, I will get 0.0015. Okay, for two-step titration, this kind, they will finish reacting with the first one first. If you realize that HCl react with both Na2CO3 and NaHCO3, these two. They will react with all the Na2CO3 first. Then, after use up all the sodium carbonate, they go to step 2. They only go to step 2 when step 1 is completely done. And then, step 2, it is a bring over from step 1. Okay? Okay, so this one, right, just use a very simple mole ratio. There's unknown X, which is number of moles. By mole ratio, I will get X mole of HCl to react with Na2CO3, number of moles. That means I will still produce X mole of NaHCO3. Okay, so step 1 is done. I bring this NaHCO3 over to step 2, copy and paste. This should be X mole. Copy and paste, bring it over. By mole ratio, the HCl for step 2 is also X mole. Okay, can follow? Until here, can follow? Okay, so that means, right, total HCl use should be 2X mole for 1 plus 2. So 2X will be equals to this total number of moles. Zero 0.0015 divided by 2, you get X equals to 0.00075. Is it? How many zeros? 3 zeros. Okay, if you find number of moles already, then you can find concentration. Divide by the 25 cm cube, and you will get the answer.
Wouldn't it be 0.00075?
Oh, 30. Okay. Okay, any question for this? Understand not? Can, right? Okay, for this kind of question, right, it is super long, and the working also super long, and the understanding also takes quite a while. So during exam technique, if you look at this question, first glance, you feel like it's a bit hard to do, skip first. Don't waste time on this long question if you can do the other question. The aim is to finish as many questions and with high accuracy. If you look at this question, you feel like, oh, I cannot really do and super long, just skip first.
Wait, for the volume, what you use for the DM3?
Volume, yeah, 25. This one.
Okay.
Okay, question 19, right? 29, sorry, 29, right? Okay, this element, they form diatomic molecules. That means X2. The MR is X. Then I have to use X. P2, okay. The Avogadro constant is L. So when they ask you to find number of atoms / molecules, always go back to Avogadro constant. This one you memorize is 6 times 10 to the power 23. Okay, 1 gram of P, this one is in 1 mole. That means I need to change it to mole first. Number of moles of P will be equal to 1 over MR, which is X. This number of moles. 1 mole of anything will give me 6 times. You give me 6 times 10 to the power 23 number of molecules. If it's atom, I need to find out in each of the molecule how many atoms I have. In this case, it is a diatomic molecule. So I need to times 2 to find the number of atoms. Okay, so number of molecules should be 1 over X, number of moles, times Avogadro constant L. But number of atoms, okay, this is a molecule. This is 1. It's bonded. This is called molecule. Atom, I have 2 atoms. 1 molecule, 2 atoms. Atom is just 1 ball. Molecule is in general whole thing bonded together. That's called 1 molecule. So for atoms, I need to times 2. So it's L over X times 2. Okay, so the answer is B. Okay, I'll go through question 30, last question. Okay, for this kind, they want you to find the volume of gas, whatever. First thing first is to cross out the chemical equation because I want to see the mole ratio. Okay, so carbon monoxide reacts with oxygen to form carbon dioxide. Balance it. Okay, so this 20 cm3 of oxygen reacts with 20 cm3 of monoxide. Write down first 20 cm3, 20 cm3. Okay, just now I already mentioned if you want to compare mole ratio for gas, you can directly compare volume. That's specifically for gas. That means what? If you look at the mole ratio 2:1 for CO and oxygen, you realize that oxygen is in excess. I only use up 10 cm3 if I want to use up everything for CO. By mole ratio, you still get 20 cm3 of product. So excess would be 10 cm3 and you produce 20 cm3 of CO2. So if I use up CO, that means I will get 0. Okay, so these two, oxygen and carbon monoxide, these two reactants, they want you to find the volume, right? Basically, they are testing you for limiting reagent and excess. Which one is in excess? Which one is in limiting? Okay, so by mole ratio, you will get 10, 0, and 20. Okay, Kivyon?
Okay.
Okay, can I check? Are you all done with MCQ? Yes. Okay, Gabriel, are you done? Okay, can. So you all can just move on to structure, and if you have any question, just let me know. Okay, Gabriel is everything. A, B, C. Sorry, A, B, C. Everything.
Yeah. Mainly A
Mainly A.
and D.
Okay, can. Okay, A, right, they actually ask for the empirical formula. So when they ask for empirical formula, always remember there is a table, right? Okay, let me show you how to draw a table first. Start with the element, what element they have. Then after that, write the percentage or the mass, the AR of the element, number of moles by dividing the percentage or the mass with AR and find mole ratio. Okay, this table is very important. Very important. Every time they ask for empirical formula, this is the table that you're gonna look for. Okay, so from the question, I have C, H, and N. So Gabriel will do first. If you can get the answer, then it's good. Okay, mean part A, is it? Okay, can. I'll just go through together how to do. Okay, first things first, basically you need to craft out a table. Some school, they are very strict. That means what? The table must close up. Some school that like don't really care, so depend on your school. Okay, first thing, just fill up the elements CHN. If you look at your worksheet, it says that I have 74.1% of carbon. And then hydrogen is 8.64. And you realize that nitrogen percentage is not given. But if it's a percentage, it's quite easy. Minus of 100% minus 74.1 and 8.64. Okay, so you will get 17.26, this percentage. Okay, AR just get from your periodic table. Look at your periodic table. Your carbon should be 12, hydrogen 1, and nitrogen 14. Okay, fill out the AR already. The third one, number of moles. Number of moles is known as mass over AR, mass over MR. So in this case, right, this on top divide by the one below. We don't care whether it's a percentage or mass. No matter what, just the first one divided by the second one, and you get number of moles. So you just use your calculator. Okay, so calculator just divide 74.1 divided by 12, etc. Okay, the last one, mole ratio. Mole ratio, basically what happened is that you see out of all these, which one is the smallest. This is the smallest number. I use the smallest number, make it 1. The ratio is 1. So I use the smallest number and I take the big one divided by the small one. 8.64 divided by 1.233, I'll get a number of approximately 7. If you use 6.175 divided by 1.233, approximately 5. Always round up to the nearest number, nearest full number, or nearest 0.5. So I repeat again, the mole ratio, use the smallest one, make it 1 equals to 1. And divide by the smallest one. Everything, all the individual number of moles, divide by the smallest one. Okay, Libra? So basically, that's how you fill out the table. And if you fill out already, the mole ratio will give you the empirical. Copy down the number. This is your empirical formula. So normally you just write empirical formula equals to this. The empirical formula, we are finding the simplest ratio, the simplified version of your chemical formula. For example, you have a C4H8. This is my actual formula. The empirical formula would be CH2, simplified version. The most simplest version of your chemical formula, but it's not the actual one. The actual one, okay, so this is your empirical formula. Copy down already. Okay, so now we look at part B. What happens is that they give you this, MR. But I wouldn't touch part B first. I think I will just add on, continue from part A. Normally the question, what they're going to do is that first thing they ask you for empirical. I would say commonly, not this question. Commonly, they first thing ask you to find empirical. The second one asks you to find the actual one. Actual one is called molecular formula. The original one, which is, for example, this. And how to find molecular formula? the question information, normally they will give you the MR. The MR of the actual formula. What the question normally gives, given the MR of the actual one. So you will take the MR of this. So I bracket C5H7N times N will give me this MR, for example, 162. If you calculate the MR inside the bracket, is 81. This is a given MR, for example, yeah, given MR. N by mathematics, so if you get N equals to 2. Therefore, your molecular formula will be equals to C5H7 9N times 2. So it will be C10H14N2. This will be your molecular formula.
How do you know it's 162 and not 149 or 303?
No, this one is just for able to understand how to get molecular. Later I'll go through part B. Okay, Gabriel, please take note. This is a very, very common question that you will see to find empirical and molecular. So know the difference between empirical formula and molecular formula. Don't be confused. One is the simplified version, one is the actual one. Okay, so you want me to go through part B, right? Okay, part B says that I have 4 different drugs and the MR is etc. 149, 162, 303, and 314. The fatal human dose is not very important for this question. They want you to determine which drug actually is the one with this percentage, etc. So this one you get empirical already. What happens that actually, right, is a bit similar to how you typically find molecular. Use the MR, see which one is the multiplication of your empirical one. Empirical is, the MR is actually 81. You need to understand that the relationship between your empirical and the molecular, they are the multiplication of it. Okay. So out of all 4, the only one that is a multiplication of the 81, the only one is nicotine. Okay, if you use 149 divided by 81, you won't get a full number. I want to get a full number because I want to prove that it is a multiplication of the empirical. Can follow? Okay, this question a bit tricky lah. It's not the typical one that you will see. So if you really cannot understand, right, don't worry, 2 marks only. Okay, can part B? Okay, so the presentation should be just use all the MR. You got 4 MRs, all divided by 81. And you show that only one have full number, which is this nicotine.
Okay, so what whole number then? Is that
Because, right, this example, look at this example. The molecular formula and empirical formula, right, they're always a simplified version. And they wouldn't have a point something. It's a very nice number.
okay, good. Thank you.
Okay. Okay, just briefly run through the last part. The last part is actually asking you to find the number of moles of the drug. And for this one, part C, we are looking at the last column of your table. This fatal human dose per kg. If I'm 50 kg, I need to times 50. So to cause the person death, right, the concentration is this per kg of the person. And mg of the drug, the mass of the drug per how heavy is the person. So they tell you that 74 kg, the person is 74 kg. So to cause the person death, from the previous question, okay, even the part B, you cannot get nicotine, right? There will be an error carry forward mark. So just continue to do no matter what. If you legit don't know what to do for part B, right, just anyhow choose one first so they can do part C. Okay, 74 kg, so I times 74. Okay, I will get 4070 mg of the drug. They want you to find the minimum number of moles of the drug. I already got the mass. What happens is I just convert the mass to number of moles and that's the answer. But first thing first, just always remember number of moles equals to mass over mR, and the mass, the unit of the mass is gram. We only use gram. If they give you kg, they give you tons, they give you mg, you need to convert to gram so that you will get the correct number of moles. This is equals to 4.07 grams. The difference is 1000 times divided by 1000. Okay, so and just sub in the formula. Number of moles equals to 4.07 gram divided by the mR. The mR is given 162. Okay, any question for question 1? Sorry, question 31. Okay, on which question? 32 is it?
Yeah, 32.
Okay, can. Okay, this one is more of application question, but if you look at it, right, it's actually titration, neutralization, acid and base. Okay, star fruit, they have this concentration of this acid. We don't care about whatever this acid is, but they just say they assume that the acid is called H2A. Okay, before we do part B, right, you need to get part A right first. Okay, part A, H2A and sodium hydroxide. You get Na2A plus H2O2. Why? Because H2A, H is H plus. If you cross over, if you need 2H, that means A is a 2 minus. You don't know what is A, but just A. Okay, part B, the student actually take out 35 cl of the starfruit juice. Okay, starfruit juice basically is just the H2A. And titrate it against the NaOH. Okay, based on the information above, calculate the maximum volume of NaOH needed. That means what? Okay, if you look at the previous paragraph, the one on top, they say that the range of concentration is probably lies between here. The highest is actually 0.02 mole per dm cube. The lowest is 0.01. If you want to calculate the maximum volume of the sodium hydroxide NaOH, that means I will need the maximum number of moles of NaOH. Okay, if I want the max number of moles of NaOH, I will also need the maximum number of moles of acid. Can follow? So if I want to get maximum number of moles of acid, which one do I use? The concentration, the lower one, the higher one?
Higher one.
Yeah, higher one. Okay. So this question, right, the hardest part is to choose which one to use. And the rest is the same. So use the concentration, the higher concentration, times the 25 cm cube, the volume, you get number of moles. By mole ratio, calculate out the number of moles of sodium hydroxide NaOH. Okay, after that you get your volume. Okay, Gabriel, right? Actually, you can try part C if you want. Just skip and try part C first. Get yourself familiarized with the empirical formula, how to do. This part C is a very classical example of empirical formula question. The AR of the individual element. Look at your periodic table. So for example, carbon is 12. Individual element. This is your data booklet. So carbon is 12. AR is your relative atomic mass, your mass number. Sorry, what's your 259?
Hydrogen.
Hydrogen. Which one? The mole ratio or the number of moles?
The mole ratio.
No. Okay, your carbon percentage is 26.7. AR should be 12. Okay, check. Your hydrogen 2.2%. AR should be 1. Oxygen is the rest, basically 71.1, and AR is 16. Number of moles, use the mass or use the percentage. So in this case, it's percentage, divide by the AR. Okay, so you will get number of moles equals to, carbon should be 2.2 something, hydrogen also 2.2, oxygen is 4.44. Do you get that? Okay, so once you get number of moles, choose the smallest number of moles and use that to divide the rest. So I don't know where you get your 259. How do you get 259?
I mistook. I wrote the oxygen and hydrogen wrong.
Okay, can. Okay, now it's 9:30. So need to end here. Tomorrow you all still have class. Okay, so happens that this worksheet up to you. You can finish it up like this week, etc. And if you have a bit of question, maybe 1 or 2 questions, you can ask your teacher. If you have more than 1 or 2 questions, basically it will take more than 10-15 minutes. Arrange a consultation with admin. Or you can keep this worksheet until like right before exam, you just chong everything as a revision is okay. So up to y'all. Okay, before we end, any question for this question? 32. No? Okay, so goodbye, good night, rest well.